Hello, everybody. Thank you for inviting us. It's a pleasure for us to be here and to present you our project called FLORA. FLORA stands for Federal Blockchain Infrastructure Asylum. Our talk is divided into two sections. The next slide, please. In the first section, we will outline the prospects of blockchain for federal cooperation. First of all, my colleague Christian will give you some information about the technical issues. Next, we will talk about the benefits of the technology for federally structures administration. In the second session, we will present you FLORA. For this, I will outline the current situation of managing the asylum process between different authorities and the challenges we have to tackle in this context. After that, we will continue by introducing what exactly we are implementing in the project. And finally, we would like to give you a brief insight into our visions. Now, let's turn to the technology, and Christian, the stage is yours.
Thank you for being here. Letting us be here. I will introduce a little bit of what blockchain is. Like this, the technology consists of lots of ideas and technologies combined, but we have like a simple example for you today, making this more tangible. So basically, blockchain works on a notebook, and you can see this notebook has like an arbitrary growing number of pages, and these pages they are considered the blocks of the blockchain. So, and all of these pages are connected to each other via the binding of the book, and you can see those this binding is the connection between those blocks. And all the participants within a certain blockchain network have or receive an identical copy of this notebook. So if we would pose a network together, all of you would have a notebook yourself, and each authority writes something into this notebook, or you would write something in this notebook, and in your own copy, and all of the entries you would put there, or the orders there, get automatically distributed among the other participants' copies. So at a certain point in time, all copies are synchronized and are identical. And so once you write the information to this notebook, it cannot be erased. If information would be erased in that notebook, all of the identical copies would be the proof of this erasure. So I erase something in my notebook and say like, hey, this never happened, this is not a fact, then all of the other participants, like you, for example, you could look at your notebooks and say like, no, I talked to the other guys, and this information is still in the notebook, and the other copies say that as well. So there might be a fault in your notebook. So that's how it works in the yeah, that's the foundation of how the idea works with blockchain. We would go to the next slide, please. So the blockchain has like 4 technological properties. Foundation, so it's it's secure and redundant data storage. So redundant because there's multiple copies of the notebook. Secure since it's cryptographically secured. There's like lots of mathematics and cryptographics behind so it's fail-safe and tamper-proof since there's multiple copies of that of the notebook, and so you have multiple instances which share the information or hold the information. And if one of the nodes actually has a problem, so you have multiple other instances which make sure that the information is still safe. So there's not a single point of failure as we know from certain older systems and architectures. We have a selective transparency. So you have limited, you can use a limited access rights they can be assigned based on certain roles and competencies of the parties involved. So you can have like different competencies and rights for certain things. You can actually make it more yeah, you can have like certain permissions and make it according to the business rules. You can have a certain transparency for your network, and so we also have like a reliable information sharing and process automation. Let's say you have a secure transfer of data. This is like the example with the notebook, so it automatically gets distributed to all the participants, and it's tamper-proof, as I said before. And also there's a tamper-proof execution of a predefined business logic. This is also or process logic. This is also really interesting technology. So you can have like a certain rule set which gets executed automatically if it needs to. So and you define that upfront and to make sure your business logic gets. So you have these business rules, this business logic, process logic, and this you can define that together with the other participants of the network and make sure you agree on that certain logic you defined together with the network participants. And also the adaptability, it's like a flexibility, technological flexibility that it can be adapted to certain local and changing requirements over time. So it's not like the blockchain is as a data structure in itself is not so adaptable, but there's built upon or certain systems which are available are adaptable, and this is one technological property which helps to fulfill certain changing requirements over time. So if we go to the next slide, I will show or explain how those principles and foundational concepts help to organize federal principles or support them. So we have the organization within a federal government or an organization of, as we have in a state, for example. So we have like empowerment. So all of the federal units, the organizations have their want to be empowered, want to be self-sustained, and we have separation of competencies, and we have, but also have like a lot of cooperation coordination because of that. And also there's an organizational flexibility. So changing requirements and things like that can be achieved while it's remain flexible. And those properties I showed you, they help they help achieving those principles, or they go good together, they fit well together. So since we have the secure and redundant data, transparency I talked, and the adaptability, and also the reliable information sharing, fits very well together to those properties. Since we have just not the technical benefits which fit to the organization, we also have a business benefits.
Okay. Yes, I want to talk about the business benefits. On this slide, you can see 4 aspects. I want to talk about the first 2 points. One of the most important benefits is that the technology supports the cross-authority processes, while at the same time taking into account the different responsibilities. That means that each authority retains its competence, its responsibility. And I want to point out the responsibility not only for the processes, but also the responsibility for the data, for the private data in this system. The second very important point is that a blockchain-based support system can be an enabler for standardization. You can offer a template for an optimal process. And at the same time, this system offers the possibility to consider particularities of the local processes. That increases the self responsibility of each location. Now you know something about the technology and its properties, and now we want to talk about our project on the next slide. Okay, then let's start with a quick look at the current situation in Germany. Of course, the asylum process is standardized throughout Germany by common legislation. That means the asylum procedure is broadly similar through the country. But due to the federal structure of Germany, the concrete implementation is slightly different. There are local variations, and it can be said the asylum management is a shared challenge with individual responsibility and with a lot of participants. Now let's have a closer look at these participants and the connection between them. For this, I want to draw your attention to the left side of this slide. Participants in the German asylum process can be public or private organizations. On this chart, you can see a selection of their structure. There are German authorities on all federal levels, on the upper and on the right part. There are other German partners, for example, language course providers, and there are international partners, like the member states in the Dublin procedure. You see a decentralized system of responsibilities, and this results in a complex network of communication relationships. In this system, each participant performs his tasks using basically his own IT solution. Of course, there are various shared IT solutions for providing or transmitting information, but just such information like about the process, about specific process steps, or about appointment clarification. Such information is often exchanged between participants via paper lists, Excel lists, emails, fax, and so on. This means a high manual coordination effort for these interagency processes. And this procedure is, of course, error-prone. It can lead to delays, and to be honest, it's not really a modern approach of communication. But this is the reality. But also for Dresden, it can be said it was the reality because we changed the system. I hope this description was helpful to understand the challenges we have to tackle, and I think you may have recognized some of them from your own practice. Now that you have heard about the challenges, let's focus on our project, which offers a solution for this. Our goal is to implement applications to support exactly this coordination of the interagency processes. And on the next slide, I will begin by running through the specific procedure at the Anke facility Dresden. There is our project located. To explain, the phrase Anke facility stands for the joint facility of the implementation of asylum procedure. The diagram on this slide shows the basic steps of the procedure. The first step covers arrival in Germany and asking for asylum. Second step is identity verification, which also covers the registration and a health check. The third step is offered advice on the procedure and consultation, and the next steps are application and a personal interview. This process looks straightforward and simple, but in reality, there are a lot of authorities involved and all need to work together. For example, the Federal Police and the Foreigner Office are involved in the first step, arrival. The second and the third steps are managed by us, the BAMF, and the Foreigner Office, but also the Health Department Dresden is involved. The last steps, in the last steps, the BAMF, we are the main actor, but we need this foreigner office to support this process. I think you can imagine that it's not easy to coordinate this overall process. The acting authorities need to exchange information about the statuses in all these steps. That's why let's focus on the next slide on the communication between BAMF and the Foreigner Office of Saxony in Dresden. This interlinked process is shown on the current slide. As you can see, both authorities exchange information about the status of an asylum application all the time. And each one needs this information from the other authority for its own tasks. Imagine in the past, after each step, the authority had to exchange paper or Excel lists or emails with this information after each step for every case. Currently, by implementation our application in Dresden, this information about the status change is written in the blockchain automatically. So every status change is immediately available and can be used by every connected authority. This was our goal, and now this is the reality in Dresden. And Christian will explain how it works on technical level.
Yes, okay. So we saw this process example in the previous slide, and you have like these certain steps and status information within this process we've just seen. And here on this slide, this information, these statuses are written to the blockchain, which you can see in the bottom part. So like a status information could be registration completed or arrival certificate issued, and there's certain different status messages or status events within the whole process, and some of them are written and to the blockchain, and some of them are read from the blockchain to coordinate the whole process. And here you see the play between certain systems. Here's an example of two authorities working together. It's the example of Dresden and BAMF. So like the local authority in Dresden. And so we have the assist system, which is the system of Saxony in Dresden. And so you have like the first two process steps, for example, for the registration part. And the system would write certain information to the blockchain, as you can see. And then the responsibility goes over to send it over to BAMF, to the federal office, and the system at BAMF at the federal office is called MARIS, and it's a workflow management system, a huge database used in the asylum process. And certain further steps are managed within this system, as you can see here with the three steps. And within the steps, while processing, the information is stored and read from the blockchain too, and read from the blockchain. And then when a certain jurisdiction is handed over again back to Saxony in a later step, then the assist system is responsible again. And as you can see here, that the systems themselves are utilizing the blockchain, but remain the main systems we used within the process management. In the next two slides, we have like a brief example on how the system looked like we developed. So yes, the next slide, please. Thank you. And so we have here this green screen you can see is from Saxony. That's the user interface for Saxony. That's how it looks like. So you have like certain steps where you can go into certain views which can be used by the local authority to make sure that the process gets supported by the system. And you have a really similar system, which looks really familiar. If you go to the next slide, you can see that BAMF Federal Office uses the same basically has the same interface, and so this is how we interact with the blockchain system. This is just a user interface, and it can be used like this in a web app, or it can also be via certain application interfaces. It can be included in the systems, in the common and more systems which are used for the process management themselves. So it doesn't have to be a web app. It can be used in other systems as well. And this is not the only thing like under the hood. We have a certain which will be seen in the next slide. And
yes, we have one more special feature in our application. The application knows the local standard process and supports the officials by following it. This business functions can be compared to a traffic light. Green means everything is okay, the procedure can go on. But as we all know, into practice, it can happen that the real process goes in another way. And for such a dissent, we defined 2 steps of warning functions. Yellow means attention, something seems to go wrong, please check it again. Red means a critical dissent, maybe even danger for health or for life. And in this case, the officials should very quickly and carefully check the situation. However, the application will only support and recommend. Only the officials make the decisions. Yeah, this is about our application. And finally, we want to answer the question, where are we now and what will we do in the next step? In April, we started testing the Flora support system in the Anker facility Dresden in real life, in real work. And the results are, first, all these Excel lists I spoke about exist no longer. All standard cases are coordinated via Flora, and our officials are very happy about the solution and don't want to go back to the old system. And currently we present the project in Germany, and on such events like today, we want to attract and encourage new partners. And I think, to summarize, we have an exciting blockchain solution that help to improve the communication and cooperation. And yeah, it could be helpful also for other authorities, for other interlinked processes.